What is a mathematical model? Okay, you take some part of the reality and represent it as a system inside your mind, and after you have this system you want to describe it, and then you describe this system in terms of mathematics with a mathematical language. You have a mathematical model of this system. So the mathematical model is just description with mathematical language of some system. And the process of the developing mathematical model from a concrete system is called mathematical modeling. Why are we interested in the mathematical models and why are they important? From some point of view, the mathematical model can be seen as a replacement of a real system. And they do this replacement because it is very easy to study this mathematical replacement, the original system, to study it. Okay, it is can be difficult to study the real system, but if they have mathematical model and, for example, we place it inside the computer, we can very easy to study it in different configurations and in different situations. They can look at this model with different angles and do the predictions. After they have this prediction of the mathematical model, they see how these predictions correlate with the real system. And if they have a good correlation, so in other words, these mathematical models have a good description and predictability of the reality, we say that this is a good model. If it is not have good predictions or description of the real system, we try to change mathematical model to have better predictions and better description of the reality. But of course it is very difficult to understand the essence of the system and describe it in all details, because the real system and the mathematical models, it's two different objects, but in some way the mathematical model somehow mimics to the real system which it wants to describe. When people start to create the mathematical models, they see that the one mathematical model can describe not only one system, it can describe very different real systems. So one model which was developed to describe, for example, one system, after the time the people find that actually this same model can be attached to describe other systems, many other systems. So when they study the only one mathematical model, we in this way study the whole class of the real systems, and this is morphism of laws that expressed by one model, and these laws actually this model find the same laws in the different real systems. So we have some isomorphism of laws in these systems, and that expressed only by one law of this model. And all this was the inspiration to create the systems theory. They say that the model, mathematical model, and the system which describe actually two different objects, and this means that the mathematical model have some properties which cannot be found in the real system that it wants to describe. But sometimes it is very interesting to study such properties, and maybe sometimes these properties will be found or predict the properties which we didn't see at the current moment in the real system, in some real systems. Actually, the people do the modeling inside our head every day. They have some beliefs and some estimations of some situations, and we believe that we can predict future in some way. And actually, this can be seen as a model inside our head, the model of the reality in which we live. Of course, this is not a mathematical model because it is not described as in a mathematical language. But if we look very attentively inside our head and formalize all the beliefs in our head, we can write all these beliefs as a mathematical model, and this will be the mathematical model of our head, which lives in our head, and which models the part of the reality in which concrete human lives.